Hello, welcome back to Math 2. This is question 2 in Activity 2, make a conjecture. So the image in the warm-up is a 90-degree rotation of the original figure. So each figure in the original figure is perpendicular to the corresponding line in the image. Use your slope calculations to make a conjecture about slopes of perpendicular lines. And I actually need to correct this to say lines. Each line. So each line in the original figure is perpendicular to the corresponding line to the image. I've defined conjecture over here. So CK12 states that it is an educated guess based on examples in a pattern. So we're going to be analyzing our table from the first question and see if we can try to find a pattern to write as like an educated guess. The first part of this question says that the image in our warm-up was a 90-degree rotation of the original figure. So if you recall in our warm-up, right, like when I look at segment AD and its corresponding line segment A prime D prime, those two lines form a 90-degree angle. And this is consistent with the fact that we had rotated ABCD by 90 degrees counterclockwise. All right. When we take a look at the slopes of AD and A prime D prime, let's see what happens. So this is from our work in question number 1, right? And I've written down the slopes for CD and DA. So DA, that is kind of the line segment that we were referring to in our warm-up. So that slope was 2/5, and then the slope of A prime D prime, or D prime A prime in this case, was -5/2. So when we multiplied those two slopes together, we got a product of -1. All right, so when we're looking at the warm-up here, the slope of AD times the slope of A prime D prime gave us a product of -1. And you'll notice in our table that actually all of these segments, all of these lines in the original figure compared with the lines in the transformed figure, when you multiply those two slopes, we are always getting a product of -1. So this is a pattern that I'm noticing here, and I'm going to write this as a conjecture in question number 2. So my first conjecture here, I'm going to say that the slopes of perpendicular lines have a product of -1. So basically, if you multiply the slopes of two perpendicular lines, you will get a product of -1. So that is the first part of this conjecture. The second part of this conjecture is going to introduce you to a new vocab word. So perpendicular lines have opposite reciprocal slopes. So we are seeing a new word here, a new phrase, opposite reciprocal. Let's take a look at segment like AB. Okay, so example. So the slope of segment AB was -2/5, right? And I'm just taking this from our table here in question 1. So slope of AB was -2/5. And then the slope of A prime B prime, so that's the segment that is perpendicular to AB here, is 5/2. So these two lines are perpendicular and they have opposite reciprocal slopes. So that means, right, our opposite is coming from the sign. So you'll see that here it was a negative and now it is a positive. Reciprocal comes from switching the numerator and the denominator. So you'll see here that now 5 is on the numerator, 2 is on the denominator. So let's break this down here. Opposite basically means flips sign, and then reciprocal flips numerator and denominator. So we can actually see, right, in our table, all of these slopes from the original figure are opposite reciprocals of the slope in the image. So let's even look at 2 and -1/2, right? Think of 2 as like 2 over 1. So think of 2 as 2 over 1, right? Opposite reciprocal means that the sign changes. So this was a positive, now it becomes a negative. And then we've also switched the denominator to the numerator, and then numerator goes to denominator. So now the 1 is the numerator, 2 is the denominator. All right. So we can see that in our table over there, and then I'll give you a few more examples here. So let's look at finding the opposite reciprocal of 2/3. So we know the sign is going to be negative, and then if we flip the numerator and denominator, that'll give me 3 over 2. We could do 5 over 4, so -5 over 4. Let's try that. Opposite reciprocal of -5 over 4. Well, I know opposite is going to be flipped from the negative, so this will be positive, and then the numerator denominator will flip, so 4 over 5. And then our last one I'll give you is, let's try 16. What is the opposite reciprocal of 16? Well, I can write this as 16 over 1. I know this is positive, so my sign is going to be negative. And then think of the numerator denominator switching, so -1 over 16. So this second part of our conjecture introduces us to a new vocab phrase in our class, opposite reciprocal. So remember that two perpendicular lines will always have opposite reciprocal slopes, and you'll be getting some practice on this in just a moment.